Chapter 4, Section 3 talks about periodic trends. The first trend we'll look at is bond radius. Now, bond radius is going to be half the distance from the center of two like atoms that are bonded together. So, if these are two like atoms that are bonded to one another, you can measure from nucleus to nucleus and cut that value in half, and that will give you the bond radius. Another radius mentioned in your book is called van der Waals radius, and it's similar except it's going to be two adjacent non-bonded molecules that you're trying to measure the distance for. And these generally aren't as precise as the regular bond radius is. The trend that we see in atomic radius, or the size of the atom, is going to be that it increases down a group, so down a vertical column. As you add extra energy levels, those atoms will get larger. Mainly, this is going to be due to electron shielding, which is, by definition, the reduction of attractive force between a positive nucleus and the outer electrons due to the cancellation of some positive charges by inner electrons. So what that means, basically, is that each row or period that you add to an atom, so as you go down the column on the periodic table, you're adding an extra row each time, you're going to be adding more energy levels where electrons can be located. Every energy level that you add gets further and further away from the nucleus. So the levels that are closest to the nucleus that are full of electrons, some of those negative electrons will cancel out some of the positive proton charges from your nucleus. So by the time you get all the way to the 6th or 7th energy level, then you're pretty far away from the nucleus, and many of those inner electrons have already canceled out a lot of the proton positive charges, and therefore the nucleus won't be able to hold the outer electrons as close or as tightly to the nucleus. So the result then is that the atom is going to grow larger. So again, the radius is going to increase as you go down a group, and it will decrease as you go across a period. So as you go from left to right across the periodic table, you're adding one more proton every element that you get to. And by adding more protons, you're going to be able to pull those negative electrons closer towards the nucleus, and that will allow the radius to get smaller as you go across. Here's just a table of that. Again, the atom size gets larger down a group, and it gets smaller as you go across a row. Now, ion radius is a little bit different. Ions aren't always the same size as the neutral atoms that they come from. If they're a positive ion, they're going to be a little bit smaller. So all the metals, because they give away electrons to achieve an octet, they will get smaller after they give away those electrons. Any of the nonmetals that will become anions or negative ions will be larger. They're gaining more electrons, so they're going to need to gain a place to put them, so they will be larger than the neutral atom. Ionization energy is the next trend, and the ionization energy is just the amount of energy that's needed to remove an outer electron from its ground state. And the trend that we see is that it increases across a period. Again, as the positive charges increases, we're adding more and more protons. That's going to hold the electrons more tightly to the nucleus, which means that it's going to be harder to make an ion or to remove those electrons. So it increases across a period, and it's going to decrease as you go down a group. The further the electrons are away from the nucleus, the easier it's going to be to pull them away. So it's going to have a lower ionization energy as you go down a group. Electron affinity is going to be the ability of an atom to attract and hold an electron. So as opposed to the ionization energy where you're trying to get rid of an electron, electron affinity is that you're trying to hold it towards yourself. And what happens here is that you are going to increase across a period, just like the ionization energy, only we say with this that it becomes more negative because you're holding more electrons, and those electrons have negative charges to them. So it becomes more negative across a period, and it also, like ionization energy, will decrease as you go down a group. That electron shielding helps to offset the positive charge from the nucleus, and that attraction to the electrons is going to decrease. So it won't be able to hold those electrons as tightly towards itself. So again, the electron affinity, as with ionization energy, will increase across a period and decrease going down a group. The last trend are for melting points and boiling points, and they're a little bit different than the other ones we've discussed. With this, we're going to focus mainly on the D block and P block. Now, when the D block and P block orbitals are half full, melting points and boiling points are going to be at their maximum, so they're going to be at their highest values. So essentially what you see is almost like two bell-shaped curves here. Lower towards the sides, higher in the middle, and decrease again. Same thing with the P block, lower on the side, higher in the middle, and lower on the far side. So right in the middle of the D and the P block are when the orbitals are half full, and that is when the melting points and boiling points are going to be the highest. Essentially, the more bonds that an element can form, the harder it's going to be to melt or boil it. So for instance, carbon, carbon's in the middle of the P block. It's got 4 valence electrons, so it can form up to 4 bonds to achieve an octet. So any energy that you would put into that would have to break all 4 of those bonds before it would ever go to melting and boiling that particular substance.